Hi, so I am doing a question here on how to prove the r cos theta plus alpha. Now this is obviously something that is used in trigonometry to solve equations. You can also use it in order to, that r value plays a very important role because it can give you the maxima as well as the minima. Alright, excuse my handwriting. Thirdly, this is obviously harmonic motions that is used in physics. But we're going to focus on the first part. Now, I'm also of the opinion that you should be aware of this particular formula. When you have cos A plus B, the compound angle, then it's cos A cos B minus, if that is a plus. So if I have plus minus, then it's minus plus over here, and then it's what, sine A sine B. I'm sure that by now at this level you are very much aware of this particular um, compound angle. We're going to use and apply the same over here. So let's start then, obviously. So you have got r cos theta plus alpha, where I can actually take out the r for now. Then I have got cos theta plus alpha. Then obviously let's just rewrite that underneath. So that's going to give me the r. Then I have cos theta cos alpha minus, because that's a plus, sine theta sine alpha. And then obviously I'm going to distribute that r over, so it's r cos theta cos alpha minus r sine theta sine alpha. So I'm just going to do one more thing, and that is I'm going to rewrite this as r, because when you look at cos of alpha, that angle, whenever you're given something like that, the angle will be something that you will have to find. All right, so that implies that cos alpha becomes a constant. So my cos alpha will be a constant and cos theta will be over here. The same I'm going to do here with r sine alpha, because alpha will be an angle, and then sine theta. Okay, so once we are there, we are going to, again, as I was saying, just to emphasize, this over here and this over here, okay, will be a constant value. It will be a constant value. The same here will be a constant value. Right. And then obviously, if you now have to write it out, you should probably get something that is identical to A cos theta minus B sine theta. Okay, where that A represents that coefficient of this whole r cos alpha will be that, and this whole of r sine alpha will be represented by that B. Okay, now let's just continue, because I will be doing a practical exercise there. So let us just now compare the coefficients. So let's say compare the coefficients. Hope I have write this correctly. Thanks to F's. So if you look at what I was saying, r sine alpha is equal to B. Okay, I could have started with the other one as well, but I want to start with r sine alpha equals to B, just comparing the coefficients, and the other one will be r. Maybe we can actually call this equation 1, and the other one will be r cos alpha. Let's say that equals to A, and that will be equation 2. So what we are going to do now is we are going to divide equation 2 will be divided by equation 1. So that will give me that r sine, of course, let us just say the way I have it, equation 1 divided by equation 2, the way I have written it down. So let me just rewrite this. Okay, let's just say equation 1 divided by equation 2 divided by equation 2. So this is going to give me equation 1, which is r sine alpha over r cos alpha. This is equal to, now that's equal to b over a. Okay. Now, if you know the r's will cancel obviously here. This is going to leave me with sine alpha over cos alpha, and sine alpha over cos alpha equals to b over a. And by now you should know of your reciprocal identity that sine alpha or cos alpha is equal to tan alpha. Okay, and then obviously for you to find alpha, you will be saying, okay, that implies that alpha will be the arctan of b over a, or the inverse. And this is something that you might probably come across probably in a formula sheet in the exams. Now, let me just bring my two equations back. My first equation, if you can remember, you can obviously, it was r sine alpha equals to b. Just make sure of that, if that was the case. Yes, r sine alpha equals to b, and r cos alpha, r times the cosine of alpha equals to a. Right, we still have them as equation A, and I still have them as equation B. So what I'm going to do is I'm going to take equation A, and I'm going to square it, and I'm going to add to equation B2 squared. Okay, so this implies that if I look at my left-hand side, I'm going to have equation A, so that is r squared. Okay, so I'm going to add the two equations together and square them, so r squared. So that will be r squared sine square alpha. That means I'm squaring both sides, okay? R squared plus, what is it? Sine square alpha, okay? Let me do the stuff on the left-hand side, okay? Plus the second one, R squared plus, R squared cos square alpha, and that should equal to b squared plus a squared. So I squared this, I squared that, and I'll add the two together. So let us see first what is it that we have. So here we can actually take out r squared as a common factor. We have got sine square alpha plus cos square, that should be a square, cos square alpha equal to b squared plus a square. I think I should add, okay, let's continue. Right, so if we're here, I think you should now be familiar with your Pythagorean square identity, where by now you should know that sine square theta plus cos square theta is identical to 1, or is equal to 1. This is something that we expect you to know. And because of that, this is going to be r squared times 1, basically, because this whole thing will equal to 1. That equals to b squared plus a squared. So this leaves us that r squared equals to b squared plus a squared. It doesn't matter. I'm just going to rewrite it under the square root as r is equal to a squared plus b squared. And this is how you will be finding the value of r. So it will just be those coefficients that you are going to take the square of. So these are formula that you will be most probably getting in the exam, okay, if you have a question like that. So let's look at a word, or at an exercise, so we can compare what is it that we got. Okay, I might have written it differently. So the question says express 2 cosine theta plus root 5 sine theta in the form of r times cosine, in brackets I have theta minus alpha, where r is obviously greater than 0, because if r is not, then obviously this whole thing will not exist, will just be 0. And the theta is an angle between 0 and 90. That means the angle that we're going to find here would be an acute angle. And then we'll be giving that angle correct to 2 decimal places. So we remember we had this, right, for alpha, we had this, where we had the value of, we're obviously going to have the value of root 5 over 2. So basically you can do this, if you want to. And then you can also find r squared as the square root of Now I'm going to take 2 squared plus the square root of 5 squared from what we had before. So this is something that you can calculate once you do know, from before. But let's just work it out and see how one can express that in that form. Okay, so if I was to do 2 cos theta plus root 5 sine theta, it's identical to r cos, and that is what? Theta minus alpha. Okay, right. So if we take the right hand side, right, and just work with the right hand side, so the right hand side will be r cos theta minus alpha. So if I take out the r, I'm going to have cos theta. Now remember, that's going to be a plus because that is minus. All right, it's going to be oopsie. Let me just show you exactly what is it that I'm doing. Okay, so it's cos theta times cos alpha minus sine theta times sine alpha. Okay, let's just clean this up. This is r cos. Okay, you can actually distribute the r over. So I'm going to write r cos alpha here and then cos theta here minus r. Then you have got sine alpha, and here you have what? Sine theta. Now, again, from my previous example where I say we are going to compare the coefficients, that means we can compare the coefficients of r cos alpha, this whole one, with the coefficient of whatever is in front of cos theta. So here, that is going to equal to 2. So imagine this is the coefficient cos theta, and this is the coefficient. The same, this is the coefficient sine theta, and that's the coefficient sine theta. So comparing the coefficients, the ones in yellow, I'm going to take square root 5, and I'm going to let that equal to that in order for us to find the missing values. Now, let's continue then and rewrite it. So I'm going to have, of course, in this scenario, I'm going to have, let's take 2. We can take sine. We can take sine. Of course, the negatives and negatives compare, so you're not going to write down the negative as it's there. So I will have r sine alpha is equal to, now sine alpha is compared to root 5, so that could be my first equation. My second equation is r sine, not sine, but r of cosine of alpha, and that is equal to, comparing the coefficient, that is equal to 2. That is equal to 2. So that's my second one. Of course, knowing these other formulas, I will get directly to the answer over here. So what is it that we are doing? We are going to say, take equation 2, or 1 divided by equation 2. So it's sine over that. So basically the r sine alpha over r cos alpha is equal to square root of 5 over 2. Right, again, as I proved you before, the r, they cancel, and sine over cos is the tangent, so tangent of alpha is equal to root 5 over 2. Of course, then alpha will be the inverse of that. Now, it's important, they are saying that maybe I must just append the page here. So let's just append the page, and I haven't thought that I'm going to write so many. So okay, so what is it that we now know? We now know that alpha is going to be, using our calculator, finding the inverse. Of course, so the inverse is going to be the inverse of tangent. Make sure your calculator is in degree mode because they gave us the domain in degrees of root 5. I have to correct that. That will be root 5 upon 2. Oopsie. Root 5. That's root 5 over 2. Okay. So we're going to get 48.18. So this obviously continues. We just capture that. Okay. So that is the solution to that. Of course, you just rewrite that. It's supposed to square root. Right. Now, we don't have to prove and show to you how to find the r, but we know that r is equal to the square root, that's 2 squared, plus the root of 5 all squared, as I have indicated before. That is going to be 4 plus 5 Okay, the square root and the root, they cancel out over here. You should definitely know that. All right, so this is equal to the square root of 9, which is equal to 3. Right, so we know our angle. We know R is equal to 3. We know that alpha is equal to 48.19. Because they were saying that we are supposed to express it in what form? Let's just go back. They say express it in that form. So we can go ahead and say, okay, let me just grab that. Okay, take a snapshot of that. This over here, all the way up to there. Okay, copy. So this is going to be, this is then going to equal to 3, and then that is cos of theta minus 48.1. This is the solution for part A. Right, now that we have that, we have got a B part. Now they are saying we should solve that equation. Now from our answer in part A, because the moment you get the word hands, it means you're supposed to use what you have in part A. From that, what we have in part B, we know that all of this is equal to 3 cos of theta minus 48.19. Just make sure we wrote it correctly. Okay, so this should equal to 1. Okay, so this should equal to 1. Now, we can isolate, and then we have cos of theta minus 48.19 is equal to 1 over 3. Now, from this, you can decide whatever, all of this can be some angle, but we know that the cosine is positive in the first quadrant as well as in the fourth quadrant. That is what we know. Okay, so we expect to have two solutions, whatever those solutions will be. Also, remember, you can obviously see where this angle is going to start from, but we're just going to calculate and find those angles. All right, so I like to say, okay, let K equals to the inverse cos of a third. That means I'm just going to find the reference angle, the acute reference angle. So if this was negative, you'll be putting a positive ratio here for you to find that K, which is like the acute reference angle. Okay, so you can know what is it that you need to do in the various quadrants depending what happens to that. Right, so if we take the inverse cosine of 1 over 3, of course that's going to give us a reference angle, which is 70.53. Can I just leave it as 70.53? Okay, we just rewrite that or take a screen capture of that. So let's see, screen capture screen. All right, so this is the solution we have. So now in the first quadrant, you're going to say in the first quadrant, okay, our theta minus 48.19 will be 70.53. This implies that theta equals to 70.53. Obviously now you're going to add 48.19 degrees, and that is going to give us 100 and, so we can calculate that. That's going to give us 118, I believe, 118.7. Okay, that is to one decimal place. All right, then so that is one solution. Then in the fourth quadrant, what happens in the fourth quadrant? So in the fourth quadrant, we're going to have our theta minus 48.19 will be 360 degrees minus 70.53. Okay, right? That is totally going to be, of course, then our theta is going to be, I'm just going to use my calculator. We're going to say, take that difference, 360. So we're going to say 360 minus 70.53. And once we get that answer, okay, whatever it is, we're going to add 48.19, 300 and something, I believe, 337.7. So that's 337.7 degrees, also correct to 1 decimal place. All right, so these are then your two solutions for this question, and hopefully it opened up a bit of, you know, a revision that you had to do whenever you are given questions of that nature. Okay, so you can always, again, as I was saying, you can always rewind the tape if I have to use the old lingua, and then you can go back and see what is it that I was doing. So obviously I started off with how to prove that, right? And then in the second question, I show you directly, as you know, this formula, you can actually find your angle and you can find the value of R without having to do all of this work. But it's quite nice to know where they come from so that you can write it in that form and then solve subsequent equations that follow.